Hi guys, before we start, I have an announcement to make that I'm gonna be hosting a full month past paper session on the coming month of April. So it's gonna be completely for GCSEs, okay, GCSEs and IGCSEs for maths. So for higher and for foundation, okay. So anyone who wants to enroll in them, they can contact me in my number. I'm gonna leave that in the description, and let's solve your math issues together. Hi guys, so today we're gonna be starting the topic of spheres in geometry. Now for a sphere, as we did before, we have done cones, cylinders, tins even. Now we're gonna see what do we get if we take a sphere. Now we're gonna have two things that you want to know about a sphere. First, let me make one here, the side, a bit bigger. Okay. Now, for a sphere, first thing we need to know, obviously, it has a radius. Okay, so here to here, that is our R. Let's mark that. Okay, next thing we want to know, what is the volume, what is the surface area? Okay, volume of a sphere would be, the formula is 4/3 pi r square. Now remember that the volume and the curved surface area, these are two things that you want to know throughout the entire of geometry, the formulas basically. Okay, volume of a cone, volume of a cylinder, volume of, you could say, different 2D shapes, 3D shapes, and then we come to spheres. And this is going to be, I think, the last topic or last shapes that we have to cover. Then we can finish geometry. We just have one more thing that we need to do. Now, we know the volume. Second thing we want to know is how to find the curved surface area. For the curved surface area, you have curved surface area. And remember, I'm going to leave the link to the notes in the description so you can access them there. But for now, only try to understand the concept. Okay. Now, formula is 4 pi r square. Simple enough. 4/3 pi r square, you know the radius, you know 4 pi r square, you know the radius, and just put in the values. Simple enough. So this is our sphere. Now, for a sphere, it's simple. What about if I split it in half? Let's take a look. Okay, now we have a hemisphere. Now in a hemisphere, we have two types. Okay, we're going to first write it down. First type. Now imagine this is a hollow, not a hollow, we could say a solid one. Yeah, let's first do the solid one. This is solid hemisphere. What does that mean? Meaning the bottom is sealed. Okay, so let's say you have this circle. So this is sealed completely. Okay, imagine yourself that you have a chocolate ball. Okay, a full, that's filled, that's completely filled, a chocolate ball that's completely filled. Okay, and then you cut it in half. So the part that you cut in half, the middle part, it's sealed. Okay, it's not open, it's sealed completely. So the best way to visualize this is, the best way to visualize this chocolate ball and cutting it in half. And don't worry about the notes, okay? I'm going to leave the link to the notes in the description so you can access them there, but for now I just want you to understand the concept. Okay, and cut it in half. So what's the concern to us? We want to know what's the volume, sir. Okay, volume is going to be, the first volume for the sphere was 4/3 pi r square. This is half of it, so it will make sense if I just do 4/3 pi r square divided by 2. Simple enough. So this is our formula for the volume. Let's mark that. Okay, now what do we want to know? We want to know the curved surface area, sir. Okay, hold your horses. For the curved surface area, let me mark that here. Yeah. 1 second, let me fix this. Okay, the curved surface area. Now The curved surface area is going to be the surface area of the entirety here, okay? The entirety. So what we're going to do, we're going to find out the surface area of this entirety and plus this surface area of the square, sorry, the circle. For this, the surface area was 4 pi r square. 4 pi r square. For this is going to be 4 pi r square divided by 2. 4 pi r square divided by 2. So let's first go here. 4 pi r square divided by 2. Why 2? Because it's half of it, and the surface area for this was the entire sphere was 4 pi r square. So half of it would be, obviously, it would be 4 pi r square divided by 2. Okay. Then also plus it will be the circle's area as well. Okay. So circle plus this curved surface area, okay, equals total surface area. Okay, so plus pi r square, this is our total surface area. Let's mark that here. And actually, let's fix this as well. This is not the curved one, but the total one here. 1 second. The total surface area. Now we have a second type of sphere. Let's first mark that here as well. Second type. Now, second type, again, we want to know the same thing applies here. That's going to be the half of it. But in this way, let me first write it here. How is it different from the first one? This is a hemisphere. With an open inside, meaning meaning it's hollow. Okay, let's mark that in red so we can properly understand that. Now, so now we know it's hollow. That means we don't have any circle. Now, to imagine this, how should I explain this? Imagine yourself that you have a ball. Okay, let's first write it here. Best way to visualize this is by seeing, not by seeing, by imagining a ball with which is empty, okay, which is empty basically, which is empty, from inside, and you slice it in half. Okay, we slice it in half. So that means no circle is here. So only we have the curved surface area. Okay, that means the curved surface area is equal to the total surface area. Okay, we also know that. So we want to know two things, the volume and obviously the curved surface area. Volume is going to be the same. Volume is same for both of them. It's going to be 4 by 3 pi r square divided by 2. That's the formula for the volume. Let's mark that here. Okay. And for the total surface area, we're just going to have the curved surface area, meaning 4 pi r square divided by 2, or you could say 2 pi r square. So in the end, what's the conclusion? Volume for both hemispheres is same, but total surface area is different. Oh. Yeah, that's gonna be it. Okay, I'm gonna leave the link to the notes in the description, so you can access them there. And if anyone wants to book a free call with me to discuss their issues in maths, I'm also gonna leave my number in the description, so you can contact me there as well. And yeah, there's an announcement that I'm gonna be holding a past paper session in the coming, you could say, I think April, for a full month. For the full month. So anyone who wants to join can contact me on my WhatsApp number, and then we can take it from there. Thank you.